All right, good evening. Yeah, my mic is working. Welcome to the first Zoom session for this iteration of the CMIS 242 course on Java programming. My name is Professor Dan Steffi. You can call me Mr. Steffi or Professor Dan or really whatever you want to. I'm not too formal on that kind of thing. So kind of how we'll have these Zoom sessions throughout the course is each week that you have an assignment due, like you do this week, we'll go ahead and do one of these. And I'd like to cover some material from the class, as well as just go over the assignment, talk about the assignment, kind of the expectations, and really kind of give you some hints for how to do the assignment. These sessions are completely voluntary. I'm not even required to do them. I just like to do them because I really think it helps the class out. But it's completely voluntary on your part to attend them. You don't lose points if you're not here. But the sessions are recorded, and I do get them posted for later viewing. So if you can't make it each of the weeks, there is a recording that will get sent out later on tonight or tomorrow. Or even if you do make it and you want to review the video later, that link will be sent out. Now, just because you're not required to be here doesn't mean you can't be here. This is the perfect time and place to really ask any questions that you have, either about the course or just programming in general. All right, so I kind of have a little list that I want to go down. Like I said, we'll talk about some class material, and then we'll talk about the assignment, and we'll also do some questions and answers. If at any point, whenever I'm going over the material, if you have any questions, just go ahead and pipe in. I don't mind if you interrupt me or anything like that. You could also type in the chat box, but the chat box is not directly in my line of sight, so I may not immediately see if you put a chat message in, but I'll certainly come back to them whenever I notice them.
Professor, I got a question for you.
Yep.
So say if, because this is kind of like a not optimal time for me, but if I got some questions to ask you, is there like a time that we could probably set it up for like maybe like a one-on-one session for a couple minutes on like a Saturday?
Yeah, we could do that. Ask me your question in email first, because I usually give really good detailed answers in emails, but if you need to set up like a one-on-one over Zoom, we can certainly do that. Just contact me via email and let me know what time. Let me know a range of times that works for you, and then I'll kind of see where in my schedule that I can set that time aside for you.
Okay, yeah, because right now it's 9:03 Monday morning for me, and I'm at work. So.
Okay, yeah, I understand the timing isn't going to work for everybody, especially people all around the world. I'm going to assume you're in Korea or Japan or something like that. I was in Japan and Okinawa, Japan at one point myself, so I understand the big time difference.
Yep, not a problem. I just wanted to check because in my last class I had an issue with one thing and we couldn't really solve it through an email, so we had to set up a time. That's the reason why I was kind of wondering if you would also do the same thing.
Yep, we can certainly do that. Just contact me via email. Like I said, let me know what times you are available, and then we'll work something out.
Not a problem. Thank you very much.
All right. Okay, so let's go ahead and get started. So, this is a course in Java. Now, note this is not the basic first level programming class. There is some expectation that you know some programming before you get here. Now, you're not expected to be a Java expert by no stretch of the imagination, and maybe this is the first time you've seen Java, and that's okay. But there is some expectation that you have at least been familiarized with programming in some form or another before you actually get to this class, since this is not the baseline class. Okay, so I'm going to use some terminology that's common in programming. If the terminology doesn't make sense, just say, hey, what does that word mean? And then we'll go and go over the definition. All right, so let's start with Java. So this is basically what the beginning of the program of Java looks like. This main here is the code that gets executed whenever the program starts up. And here I'm just saying, I want to print this string, print this out to the screen, right? So let's just run this. And by the way, this IDE I'm using, IDE stands for Integrated Developer Environment. This is IntelliJ IDEA Community Edition. It's free. You don't have to use this. You can use whatever you want to do your programming. You can use Notepad if you want. You can use Notepad and the command line to compile it. That's perfectly fine if you want to do that. I like using this because it does a lot of this fancy coloring of the words and stuff like that. It does a lot of highlighting that I like. But it's just my personal preference, and you can use whatever you want. Because at the end of the day, whenever you submit your assignments, the only thing that you're turning in is your .java files and a document file. But you'll see that in the actual assignment. Okay, so we're just going to have it print out hello world to the screen. So I'm going to run that in my IDE. It's going to do some compiling. And here is where it puts the output in my IDE. And there enough, it says hello world. Let's just say hello world again. Let's compile it and run it. It's compiling, running, there we go. Hello world again. So this is the basic baseline Java programming. Main is where the program starts executing. And this is what I'm telling it to do. I'm just telling it to print out a string. Okay, that's programming, kind of 101. So let's talk about the material for the class now. So the material for the class talked about objects, instance methods, and instance variables. So what is an object? Java is in what we call an object-oriented programming language, meaning you want to structure your program to represent real-world objects. And what do I mean by that? Let's imagine that we have a door, okay? A door is a real-world object, right? Well, let's make some code that kind of represents that object. It represents a door. So I'm just going to make a new file, a new Java class, and I want to call it door. So now I have this new Java file. It's called door.java. And here's where I want to put in my code to represent this object. This door is going to be an object, and it represents a real world door. Okay. So let's talk about instance variables. So what a variable is, it's a piece of data that describes your object. So what could we use that describes a door? Well, a door can have a color, right? So let's have a variable that tells us what color the door is. I'm just going to put it in a string and we'll call it color. And I'll explain what the private means in a minute. What else describes a door? Let's say how big it is, how many inches wide, how many inches tall, okay? So say inches tall and inches wide. That's something else about a door, right? And let's just stop there. There are many more things that describe a door, but for our short example, we're just going to have these three things that describe what a door, it's going to describe the properties of a door. It's going to be the color, how tall it is, and how wide it is. Okay, that describes our door, and this door is our object. So those are what we call instance variables. They're variables that describe your object. Okay, so now we have instance methods. What that is, think of it like the verb that you can do with the door. It's not always a verb, but that's a good baseline to think about. And here's what they look like. So we'll make these public, and I'll explain this in here in a second. Let's make that smaller so we can see it. Okay, so we'll say these are our instance variables, and these are our instance methods. And I'll tell you what the private and public means. The private means I can only access this variable inside of this class. That's what private means. It means to the outside world, to any code outside of this door class, I cannot access these variables. Public means I can access it. So you may say, well, why don't I just put public here? And so that, you know, in code outside of this door class, I can just find out what the color is. It is very, very poor coding practice to make instance variables public. It's industry standard, and it's just bad practice to make them public. And the reason being, you do not want to allow code outside of your object to change the object. So, and we'll see that in a second whenever we go back to the main and actually make a door. I'll give you some examples of that. But for right this second, you should just always remember that instance variables should always be private. There is a third thing. Like I said, there's private, there's public. There is a third one called protected. We're not going to get into that yet. We'll talk about protected here in a couple more weeks when we talk about inheritance. That's a few more weeks away. But no, there is one called protected, but we're not gonna use it for a couple more weeks. Let's go back to private. All your instance variables should be private 99.999% of the time. There really is extremely rare circumstances where public is a good idea. And those are extremely rare and far between. So just know off the bat, make your instance variables private. Okay, so let's talk about instance methods. Our methods are things that we can do with our door. Okay. Generally, you want to make them public. There are reasons to have them private, but you generally want to make them public. And it's kind of the opposite of the instance variables. Is while we don't want to change the description of the door from the outside world, we do want to be able to interact with the door, and methods are how we interact with the door. Now, this is a special method. It's called the constructor. We know it's the constructor because the name of the method is the exact same as the class name. That means it's a constructor. So when we're back here in main, let's say we want to make a new door. So let's just leave it like this. So far, we have this door object and it has these instance variables. It has this constructor called door. So back here in our main, outside of the door, you know, this is in our main class. Let's make a door. And how do we make a door? It's the class name door, a variable name, and you know, variable names can be really whatever you want it to be. I'm just going to call it A. It'll equal a new door. And that makes a new door. Now, the thing is, we can have two doors. Now we have two doors, and they're in the variables A and B. Let's make a third one. We can have as many doors as we want. And each one of these is a separate object. This is object A, and it's a door. This is object B, and it's a door. This is object C, and it's a door. This door is completely separate and independent of this door. They all use the same code, but they are independent doors from each other. And as you see here, we do new door. This door is calling this constructor right here. It's calling this method. So this is what makes our new door. So we need to do some thinking here. Whenever we have this door constructor, this is where you want to initialize your instance variables. Right now, your variables have an unknown value. We haven't assigned any kind of value to our variables, right? So what is the color? We don't know because we haven't made it equal to something. The same thing with how tall it is and how wide it is. We don't know how tall and wide it is yet because we haven't assigned them. Well, let's set them to some value. Let's say the color is equal to red. Let's say the inches tall is equal to 60. I think that's a short door, but it's fine. And we'll say the inches wide is 48. Okay, so now we are setting the properties, we're setting the description for our door. So in our main, when we make a new door, it calls this constructor, and then this constructor sets up the description of our door. It's going to say, well, it's a red door, and this is how tall it is and how wide it is. Okay, so now we really have kind of a complete door object, and we've made this new door. Now let's do some stuff with the door. Okay,
Hey, Professor, I got a question for you.
Yep.
So going back into the constructor, if you wanted to have the user input the data instead of you assigning it, how would you do that one?
Yep, we're going to get to that in the next part of it.
Okay.
All right. So here we're making the doors. They're not doing much right now. We just made the doors. You know, let's do something with them. Well, the first thing we want to do with them is let's print out the information in the door. Okay. So let's make a new method in here. This is a very common one for Java objects called public to string. This is a public method, meaning I can call this method from outside the class. This is the return type. It's going to return a string. And this is the name of the method called toString. Most Java objects will have this method right here. And what you want to do, you want to make a string representation of that object so that you can actually print it out and see what's going on. So what we will do, we're just going to make a string that tells us the color and how tall and wide it is. So let's just make a string that says that. So I have a string S, it'll equal to the color, plus we'll put a space in there, how tall it is, and then how wide it is. And then we'll return the string. So what's doing? We're making a string. The first thing in the string is the color. Then we're going to put a blank space. Then we'll put how tall it is. Then we'll put a blank space. And then we'll put how wide it is. And then we're just going to return that string. So let's go back to our main method. And let's get rid of, well, we'll keep these other doors for now. So for door.a, let's print out the description of door A. So we can do the system.out.print. We can do a.toString. And why is that? Because when you print something out, you want to print out a string. Well, A is the door. We're calling the toString method on that door. And so if we look at the toString method, it returns a string. And that's what the string looks like. So a.toString is a string. So let's run this. And what will get printed out is right here, instead of hello world again, we're going to have the door printed out. And that's what it should look like. It should be the color, how tall it is, and how wide it is. Let's run it. There we go. So we get, it's red and it's 60 inches by 48 inches. Okay. And now if we do the same thing for B and C, if we run that, what we'll see is we get all three printed out. Now, they all print out the same thing. And we're actually getting ready to get into what Robert was talking about here in a second. So we're printing out all the doors, but they're all printing out the same thing, right? And that's because in the constructor, we made all the doors red. We made them all 60 inches tall and made them all 48 inches wide. Well, all doors are not red in those dimensions, right? So how can we tell this constructor, I don't want it to be red. I want it to be something else. And the same thing for the size of it. I don't want this size. I want a different size. Well, we can give parameters, also called arguments. Sometimes I'll say parameters, sometimes I'll say arguments. It's the same thing. But we can give parameters in here to tell the door the description, like this. So we can say the string, we can say the color, we can say how tall it is, and we can say how wide it is. So these are variables we're giving, these are parameters we're giving our door. And this is the color, how tall it is, and how wide it is. So we need to save that information. So when I have this dot color, I'm talking about the door's instance variable color. The this dot inches tall is the instance variable. The this dot inches wide is this variable. Those are all the instance variables. So I'm going to make the instance variable color equal to this color. The inches tall is going to be this tall, and the inches wide is going to be this wide. So now I have a door constructor, and it has 3 parameters, which is the color, how tall it is, and how wide it is. But now this causes a problem back in our main function. And what problem does it cause? When our main function, we called the constructor, but we didn't put any parameters in here. That's why in my IDE, you're seeing the little squiggly line. It's telling you you've done something wrong here. And that's because we're trying to call the constructor, but with no parameters. And if we look at door, our constructor has 3 parameters. So we need to give it 3 parameters. So for our first door, we'll make our first door red, and it'll be 30 by 20. I know that's a short door, just bear with me. For our second door, let's make it green and 50 by 60. Okay, just some random numbers. For a fourth door, let's make it, third door, let's make it blue, and it's 55 by 88. You know, I know those aren't realistic numbers for a door, but I think you see the point. So here, I'm making a new door. That's the color and that's the size. This door is going to be green with the size, and this door is blue with the size. So now when I print them out, instead of getting all red and same size, I should get the accurate description of what I've said the door actually is. Let's run it. Now you see when we print it out, we get the first one is red and 30 by 20. And sure enough, it is red 30 by 20. Green 50 by 60, green 50 by 60, and then blue 55 by 88, and there's blue 55 by 88. So that's how, instead of in the constructor, you know, I did have this kind of red, meaning every single door I make is going to be red. So now we're going to let the main program tell us what color it is. And so we're going to say it's red. So that's that's 2 instance variables, instance methods. So we have the constructor and we have the toString instance method. Let's add one more, and then we'll kind of wrap this example up. What else can we do with the door? Let's think of 2 things we can do with the door. With the door, we can, actually, we'll just do one. We can open and shut the door, right? Okay, so let's have a instance variable, instance method to shut the door. Let's have a method to open the door. Okay, but now we need to think about, well, how do we shut a door? How do we open a door? How do we model that with our object? Right, so just like here, we kind of remember the color and the size. Let's remember if it's open or shut. Yeah, it changes, what I'm doing here, this is good programming practice. It's not required of you, but instance variables in the real world are generally started with an M underscore, and the M just stands for member, like it's a instance variable. You don't have to do that. I like doing that though. Let me change under that. No requirement on your part. It just, whenever you're looking at it, it helps remind you that that's an instance variable. Starts with M underscore. Okay. So going back to where we were talking about an open and shut door. Okay. Well, here we're going to have a Boolean, which means it's either true or false to if it's open, right? So if open is true, then the door is open. If open is false, then the door is closed, right? So if we shut the door, open should be false, right? Because it's no longer open. If we open the door, open should be true because the door is open, right? Let's add that into our toString so that we know if the door is open or closed. So we have this string here. Then we'll say if the door is open, let's add some more to the string. If it's open, then we'll say it's open. Oops. Else, it must be closed, right? So what I do here, so we had the same string we had a minute ago. Now I'm going to say if the door is open, then I'm just going to add on to that string the word open, so we know the door is open. Else, meaning it is not open, I'm going to add on to the string that it's closed, and then we still return the string. So let's go here. So we can do something with the constructor. We need to set that open value. What do we set it to? Well, there's one of two ways we can go. We can make another parameter on here, is open, is open. We could do that and just have the main method tell us if it's open or closed. And then we have to go back over here and put true or false if it's open or closed. What we could also do, we could just say all doors by default are closed. So you don't necessarily have to put all of the parameters in here. Here we're putting color, tall, and wide, which are those three. We still have open left over, so we can just assign it a value if we want, or we can give it as another parameter. Here, I'm just going to choose, I'm making a design choice that initially, whenever you make a new door, open is false, meaning it's shut. Okay, so let's go here and let's run this now. And remember, now when it does the toString, it should say whether the door is open or closed. Let's run it. And there we go. All three of the doors are closed right now. Why are they closed? Because initially the open is false, meaning it is closed. There's where I say it's closed. And I didn't open it. But now, let's get rid of these other doors. Let's just look at door A. So let's make door A, we'll make a new door. We're going to print out door A, and then let's open the door. Now let's print it out again. What's going to happen? Here we go. So there the door is the first time, it's closed, and now the door is open. Can I make that bigger? Yeah, there we go. I can make that bigger. There we go. So now the door is open. Well, let's shut the door again. And now it should be back to closed, right? Let's run it. There you go. So the door started off closed. Whenever we made the door, it's closed. We're going to say this door, we're going to open the door. And when we print it out, it says it's open. And now we're going to shut the door. And when we print it out, it says it's closed. So that is an example of an object, meaning we have an object called door. It represents a real world physical door. These are the instance variables. This is the description of the door. It says what the current state of the door is. And 99% of the time, make them private unless you have a really good reason not to. This is a public instance method. This is a special one because it has the same name as the class, meaning this is the constructor. I give it some parameters. I set up the parameters of the door. I assign values to the instance variables. Here I have an instance method called shut, meaning whenever I shut the door, I'm going to change the state of the door to where open is false. Here is a instance method called open. If I open the door, then I'm going to set its internal state where open is true. Here's an instance method called toString. It returns a string. And this is how I'm just going to construct a string that describes my door so that from the main method, I can print it out. One additional extension I'll make onto this, and then we're going to wrap up the objects. Let's get rid of these other ones. Let's get rid of all of them. So let me keep that. So let's make a new door like this. So Robert had asked, how can we allow the user to type in the information on the door, right? Well, we need to get input from the keyboard, right? Here's how we get input from the keyboard in Java. We have a thing called scanner. It's an object. Make the variable name is new scanner. I think it's system.in. Yeah. This is just prepare to get input from the keyboard, right? A scanner, just like this, you'll construct it the same way every time. This lets us get input from the keyboard. Let's first we'll ask the user what color the door is. So ask user what color is the door. So we'll do system.print, system.out.print, print what color is your door. And now we'll let the user type in what it is. So the color will be the scanner next. What the scanner.next is, just think of scanner represents your keyboard. And when you do .next, it returns the next string that you type in on the keyboard. The next, yeah, it returns the next string you type in the keyboard. So now let's make a door. So instead of putting in red here, let's just put in color. And then we'll print it out. So let's watch what happens. We run it. So here it's saying, what color is your door? Right here. So we already made the keyboard input. We're saying, what color is your door? Now it's waiting for me to type in something. Let's type in orange. Hit enter. And there we go. So this color was whatever I typed into the keyboard. I typed in orange. So now color is the string orange. And now when I make my door, I make it with that color that I typed in. Now what happens if I don't type in a color? What happens if I type in ASDF? What's going to happen? Well, my program sure does think that's the color, because I'm not doing any kind of checking in here to make sure you typed in a valid color, right? I'm not saying, oh, is what you typed in an actual color? You know, I didn't do any of that kind of checking. So For this course, I'm not requiring you to do any kind of checking to make sure the user typed in the right thing. You can go with the assumption that the user did type in the right thing. But I will say in real world programs, 100% of the time, you need to check what the user is typing in to make sure it's valid input. I'm not going to make you do it for this class, but when you get out into a production corporate environment, you always have to check the user input.
Professor, question.
Yep.
So the scanner method for user input would work the same way as if you initiated a menu in a method, would work the same way. You would just have to initialize what so say, using this example, the string color would equal your selection in the menu, correct?
If I think what you're saying, so let's say you did something like this, system.out, print, oops. Something like this. One, let's just say 1 is red, 2 is blue, 3 is green. And then you're going to say, enter your selection. So that's kind of like a little menu here, right?
Mm-hmm.
So now at this point, let's say the color starts off to be, I don't know, and whatever you're going to put there. And so now, oh, sorry, that's the thing. We can have the string, the selection is equal to the scanner.next. So now selection will be whatever they type in, right? And you're expecting them to type in a 1, a 2, or a 3. So here you can say if the selection equals 1, or oops, and color, then the color will be red. Else, if the selection equals 2, then the color will be blue. I'll zoom out from this in a second so you can see the whole thing. Else, if the selection dot equals 3, and color equals, what I said it was, 3 is green. Yeah. Green. So now I can do, yeah, like that. So let's go back out. Let's look at this. Color, yeah. Color equals no. All right. So this is like a little menu. I'm going to print out this menu. I'm going to say, put in 1 for red, 2 for green, blue, 3 for green. Then I'm going to say enter your selection. The scanner.next is going to get whatever they type in. And so if they type in a 1, then I'm just going to make the color red. If they type in a 2, I'm going to make the color blue. If they type in 3, I'm going to make the color green. And then when I make the door, I'm just going to use that color. Let's run it. Here, we get this little menu here. 1 red, 2 blue, 3 green. Let's say we type in 2 for blue. And then we made our blue door. Likewise, if we run it and we type in 3, we get a green door. So that's how you can kind of use a menu to let the user select something from the menu.
So it would work the same way as if you had a menu in another method and you just called the menu from that method in and do the selection. You just run the if statement.
Oh yeah, if you mean something like,
because I prefer to put my menus in a different method.
yep, that's fine. Let's say you have this right here. Let's copy all that. So let's say we have this method called do menu. Okay. Let's make our scanner system.in to get input from the keyboard. So we'll have this method called do menu. We'll make our keyboard input. We'll show the method. We'll print out the menu. We're going to get their selection, and then let's just return the selection. So now in the selection, you can check it up here. You can have, let's see, string selection is equal to do menu. You could do that. But also, if you wanted to, you could put the whole color thing down here. So instead of returning the selection, let's return the color. So what are we doing in the method? The do menu, let's say do color menu, so we know what we're talking about. So if I call this method, we're going to make the keyboard input. We're going to print out our menu. We're going to get their selection from the keyboard. Based on that selection, we're going to choose one of these colors, and then the method can return that color. That's why it returns a string. So now we can have the color is equal to that do color menu, and that works just fine. When we run it, effectively, you're not going to see any difference here because at the end of the day, it runs the same, but you've broken it up a little bit into another method. So yes, you can put your menus in a separate method. There's nothing wrong with that. And so then, of course, if I select 3 for green, I get a green door. If I put 1, I get a red door.
Okay, so my issue, I figured out what my issue was. I miswrote one of those lines, and that's the reason why it wasn't registering my user input.
Okay.
Got it.
All right. Okay, so we covered objects, instance methods, instance variables, making an object. This is where we make the object, like we've already done. We're making a door. Let's talk a minute about encapsulation. I've already been talking about some, but encapsulation means whenever we have an object, we don't want to make things public that should not be public. Meaning the internal state of the door, the description of the door should remain internal to the door. And we only make things public that we want the user to be able to do with the door, right? So here we want to let the user shut the door. We want to let the user open the door. What we are not allowing them to do is they can't change the color. They can't change how big it is. They can change if it's open or closed, but only by using these public instance methods. So let's imagine we want the user to be able to paint the door, right? So how would the user paint the door? So to paint the door, what it really means is we change the color of the door, right? So can we just change the color of the door? Can we do a.m_color equals purple? Can we do that? The answer is no. And you can see it's showing up red here because my IDE is telling me, you can't do that. Why can't we do that? A is a door and m_color, that is the color, right? But it's private, meaning I can't access it from my main method. I can't access it from outside of this door class. You could make this public, and the thing is, it will work. So if we see here, let's make a door of whatever color. Then we're going to change the color to purple, and then we'll print it out again. Let's run it. And we'll put 1 for red door. And as you see, it prints out a red door. Then we change the color to purple. So now it prints out a purple door. But this is very, very bad practice, and it breaks encapsulation. Like I said, encapsulation means the internal state of the door cannot be modified directly. So let's change that back to private. That's why you have these as private, to enforce that you can't change them externally. But let's say we still want to be able to paint the door. Well, let's just make a new method to paint the door. Let's make public void, let's just call it paint. And what is the new color of the door? Well, let's give it as a parameter, the new color. So now in here, we can say the color is equal to the new color. So now we can paint the door by using this paint method. We can change the color of the door by using a public instance method. So now this doesn't work anymore, but a.paint works. Let's make it purple. Let's run it. There we go. We'll start out with a blue door. So there we go. We have a blue door. We paint the door purple and print it out, and now we have a purple door. So that's what encapsulation means, is that the internal variables, these instance variables, should almost never be public. 99% of the time or more, they should be private. And if you need to do something with it, then you give it, one of these methods, one of these public instance methods to change the door if you need to change the door. Okay, so that gets us caught up to where you are in the class right now. Right? I'm going to spend a little bit of time on your assignment, and then we'll have any closing questions you may have. Okay, let me bring up the assignment on the screen to make sure I don't miss anything. Let's see here. Yep, there we go. All right, so your assignment is about making a weight class, and your weight class has pounds and ounces in it, and it tells you exactly what to do with your weight class. It says make a constructor, make this method, make that method, make this method, make that method. And then in your main, you have to make a bunch of the weights and then do stuff with them, right? That's what your assignment boils down to. So what I'm going to do today, I'm going to give you some code to get you started on the assignment. I'm not going to do the whole thing. I do not give out answers to assignments, but we'll do the first few steps to kind of get you started in the right direction. And I'll do that for this first assignment. For subsequent assignments, I probably won't give you any code, but we'll do examples in future assignments. But for this assignment, I'll give you a little bit of a leg up and get you started. Okay, so if you have the assignment open, the best way to tackle these assignments is really just to read it line by line, and it tells you exactly what you need to do. So for this, let's delete our door. We don't need our door anymore. Where's delete? There's delete. And we don't need door anymore. Delete anyway. We don't need this color menu anymore. We don't need any of this code in main. So we have our blank main function, right? There we go. Starting from scratch. So let's just kind of read it line by line, starting with the third paragraph, because that's where all the stuff happens, all the descriptions of the assignment happens. So I'm going to read the description, and then I'm going to do that portion on my screen, so you can see how it translates line by line over to exactly what you should type in. So if you read it line by line and you implement one line at a time, you should have no problem with the assignment. So let's start off with, it says the first class is the weight class, and this class will have two instance variables. So that tells me I need to make a class called weight. W-E-I-G-H-T. There we go. And it has two instance variables. The name of the first variable is pounds, and the data type is of integer. So it's an integer, and it is pounds. Now, like I said before, all your instance variables should be private. So that's like the first two sentences. That is, the first class is the weight class. The name of the first variable is pounds, and its data type is integer. Okay. The name of the second variable is ounces, and the data type is double. So let's make another one called double. ounces. Oops, oh, right. Okay, that's the first two sentences. And then it says both the instance variables must be private. So we have that. So this right here is the complete paragraph 3 of your assignment. Line by line, it translated into exactly what I needed to type in. I'll do 2 more lines from this weight class, and then I'm going to stop there, and you'll be responsible for the rest. So it says the weight class should have 4 public methods and 2 private methods, which are as follows. And we'll do the first 2. It should have a public constructor, so it should be public. The constructor has the same name as the class. A public constructor that allows the pounds and ounces to be initialized to the values supplied as parameters. So it needs to have parameters that are the pounds and ounces. Okay, and the values need to be initialized to those parameters. So this dot pounds is equal to pounds. This dot ounces is equal to ounces. There we go. That is line 1 of that assignment. And just that single line tells me exactly what I need to type in here. All right, we'll do line number 2 now, and then we're going to stop there. So a public instance method named less than. So a public instance method named less than. That accepts 1 weight as a parameter. Weight. 1 weight as a parameter, and returns whether the object is less than the weight parameter. So it should return true or false to make it a Boolean. So we have a public instance method named less than that accepts 1 weight as a parameter, and it will return true or false. It will return whether this weight object is less than this weight object. So how can we tell if it's less than the weight? Well, you got to do a little bit of math in here, right? So how could we calculate if this weight with this pounds and ounces is less than this weight? Well, we'll do it like this. We'll say if this pounds is less than the weight pounds, we'll return true, right? So if this pounds is 5 and this weight has 7 pounds, then it's going to be true, right? This pounds less than the weight pounds. Okay. Else, if the weight pounds is less than this pounds, what should we have here? It should be false, right? Because if this weight has more pounds than this, then it's not less than, right? But now we have a third option. What's the third option? What if the pounds are the same? If the pounds are the same, then we have to start comparing ounces, right? So we can say if this ounces is less than weight ounces, so return true. Else, we can return false. That's all there is to that less than. So, in the description of the assignment, it doesn't tell you how to do this internal coding part. That's for you to figure out. We've done it here, but for the other methods, you have to figure out what code makes that method work based on the description of the method. So we'll go over this one more time. A public instance named less than that accepts 1 weight as a parameter, and it returns if this weight is less than that weight. And this is how you check which one is less. If this pounds is less, then it's the weight is less than. If the weight pounds is less than this, then it's not less than, and so on and so forth. Okay, there's more methods to the weight. That is for you to do for the assignment. I will talk about what it's expecting in your main method. So let's go to your main method. So if we look further down the assignment near the end of the first page, it talks about, in addition, okay, there we go. Okay, here we go. The second class should be named Project 1. All right. So let's make a new project, new class called Project 1. Zoom it in. Okay. We'll look at actually we're going to look at number 3. Okay, we'll look at number 3 in those line items for project 1, and we'll do number 3. Okay, so what's it tell you to do? It says a private class method named find average. So I have a private. We don't know what the return type is yet. Well, we don't know what we want to return yet, but it says find average that accepts the 3 instances of weight as parameters. So there should be a weight 1, there should be a weight 2, there should be a weight 3, and returns the average weight. So it's going to return a weight that is the average. Okay. So let's figure out, how do we find the average of these 3 weights? Well, you can think of it, it's not that different than finding the average of just some numbers, right? So let's imagine I have the numbers. So imagine I have the numbers 5, 10, and 15, right? How do I find the average of those 3 numbers? Well, I add them together and I divide by 3, right? That's how I find the average of those 3 numbers. I add up the numbers and then I divide by how many numbers there are, right? Well, finding an average weight isn't much different than that. We'll add up the 3 weights, and then we'll divide it by 3. Now, it's not as easy as that, and that's because a weight isn't just a single number, right? It actually has some pounds and ounces in it. So what we have to do, you have to find a way to add the 3 weights together. And it just so happens, if we look back up in the assignment at line item number 3 for the weight class, you have to make a public instance method named add2 in the weights. So somewhere here in the weights, you have to make a method called add2 with this as a parameter. I'm not going to do the work in here for you. You're going to have to figure out that work, right? But here is how we can add 2 weights together, right? So we could take weight, W-E-I-G-H-T, if I can spell right. We could say the average is equal to, well, first we got to get the sum, right? The sum is going to start off being 0. Right, there we go. The sum starts off being 0. Now we're going to add on to it weight 1. We want to add on to it weight 2, weight 3. So now we have the sum of all the weights. And now we need to divide by 3. Need to divide by 3. And I'm going to leave that exercise to you. But that's how we can find the average of 3 weights. And this is kind of line item 3 under your project 1 class that it tells you to make. One more time, add a private class method named find average that accepts the 3 instances of weight, that's 3 weight instances as parameters, and it returns the average weight. So it returns a weight. So you need to compute the average. The sum starts out to be 0. You add each weight to the sum. Now here you need to divide by 3. This is for you to do the division. And then you can return the sum. But at this point, the sum is going to be divided by the 3. So it will be the average. Okay. That's as much as I'm going to give you for the assignment. I think that's a lot that's already given to you. But I think that should give you a good leg up to get started. Future assignments, I probably won't give you this much to start with. Yeah, but there it is. So we'll spend a few minutes on questions and answers, any questions you may have. It can be about the material we went over. It can be about the assignment, but it can also be any other Java or programming class question or anything you want to know about the class. So mic's open.
I have one question about the assignment. Just to confirm, kind of check on it. So with the 3 instances, are you looking for, do you want it to be user input scan, or are you just saying we put in the weight ourselves to test and run?
So it's actually a good question, and here's what I will tell you. Follow the description in the assignment exactly.
Okay.
That is what I'm grading off of. So if the assignment tells you to have the user input it, then have the user input it. If the assignment tells you that you should just hard code in the values, then you're hard coding the values. And right here on the second page of the assignment, it says the input values are hard coded within the program. And what that means is, so in your main, when you're making your weights, what it means to hard code is you manually specify the values, right? Something like, so I have weight 1, weight 2, weight 3. And then I just type in whatever the values are that I want. That's what it means to hard code the values in. You're not letting the user input the values, you're just putting them in the code. And so since the assignment says hard code the values, that's what you should do. There should be no user input for this first assignment.
Perfect. Thank you so much.
Professor, I got a question for you.
Go ahead.
So I'm more familiar with Python than I am with Java. How similar would you say Python is to Java?
Very similar. Especially if you're familiar with Python classes. Java classes and Python classes are extremely similar to each other.
Okay. Yeah, because I've taken 2 Python classes, and this is my 2nd Java class, and Python just seems so much easier.
I would say that's probably because it's what you're familiar with. I think you will discover over time, and I learned this lesson many, many years ago whenever I first started programming, is once you learn a programming language, it's not that difficult to pick up other programming languages. And the reason is kind of the logic behind programming is all the same. Almost all programming languages have methods or functions, as they're called in other programming languages. All programming languages have variables. All programming languages, get input from the keyboard. All programming languages print stuff out. All programming languages have loops and things like this. And logically, they all operate the exact same way. Now, what the code, the words you actually type in here may be slightly different, but the logic and concept behind them are all the same. So if you know that you need to, let's say a loop, right? So a loop in Python looks like this. Was it like for I in range 10, something like that. Do something with I, right? That's what a loop looks like in Python, okay? Now, a loop in Java, it follows the exact same concept, just what you type in is slightly different. So in Python, this will do a loop 10 times. In Java, it looks like this. Do something with I. So the kind of what you're saying to do here is almost the exact same, just what you actually type in is slightly different, but the logic and the concept behind it is the same. So once you know one programming language well, it's fairly easy to pick up other ones.
Okay, so yeah, like with Python, you usually do a counter to hit it to where you want it to go. And with Java, you just put in, okay, the range is going to go, for like this example, the range is going to go to 10. You don't have to put in the counter. It'll just automatically run out to and loop 10 times.
Well, like this bottom one, this bottom one is Python. So this bottom one, that loop is going to Python. I mean, this is Python loop right here. I don't have a separate counter variable. I mean, you can incorporate it like that into Python, but you don't have to. So these two right here, I think these two are extremely similar. Here, you're just saying the I is going to start at 0. This is, I want to keep looping as long as I is less than 10. And then each time in the loop, I'm going to make I go up by 1. That's really the exact same thing that's happening here with this Python, is I is going to start out with 0. It's going to keep counting until it gets to 10 or 1 less than 10. And each time it goes up by 1. So if I were to do something in here like print I, keep in mind this part down here is Python, and this system.out.println I. These two things are going to print out on your screen the exact same identical thing. It'll print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Both of them will print out the exact same thing.
So pretty much it's just a little bit of the key terms on how the functions work. Change.
Yeah, exactly. Like I said, what you type in looks slightly different. I don't even think these look very different. I mean, obviously there are differences in what you type in, but you know how a for loop works, the logic behind it, there isn't any difference to how the logic behind it works.
Okay, that answered my question.
Okay.
Thank you very much.
Hi, this is Fatima. I have a question.
Yep, go ahead.
So my question is, when we submit our assignments, do you expect to have one Java file, or can we submit like the main file and then whatever the other file, the test file, or do you want everything just like in one file?
No, each Java class should be in its own file. So if you have 3 Java classes, you should be submitting 3 separate Java files.
Okay, perfect. Okay, thank you.
Yep. I'll hang on for a couple more minutes to see if there's any last minute questions. While I'm doing that, just a reminder, I did record this session. I will record all the Zoom sessions we do. and I get I get it posted on YouTube, sometime later this evening, and I do get that link sent out via email so that, if you need to go back and review something I talked about earlier, you can always go and review that video whenever you want. Yep. So stand by for a couple more minutes. If you have any last minute questions, let me know. And also you can email me anytime, and I can usually get your response back within 12 to 24 hours at latest. All right, nothing else heard. We'll go ahead and wrap this up, and I will get that link sent out shortly. All right, everyone have a good night. Oh, also, shoot, I think somebody dropped off. I know that this time is not the best for everyone, but if this time does not work good for you, then please go back into that questionnaire link email I sent out, about a week ago, and vote for what you think is the best time and day of the week for you. And if it changes what works best for everyone, then we'll adjust our time as well. All right, so everybody have a good night.